Hello? Oh, sorry, that might have been a bit loud. Is that better? Hope that's better. Very odd. That might have improved it a little. I've just switched microphone. Ah, there you are. That's why it's always important to pick the right equipment. So, sorry about the audio problems, folks. Let's get on with the stream. Anyway, so this robot has 4 sensors. We can actually see what those sensors are if we click this little tab called Robot Configuration. It tells us all the details we need about our robot. So in sensor slot 1, we've got a touch sensor. So the robot knows when it's being touched. We've got a gyroscope, so the robot knows its position. We've got a color sensor, so the robot knows what color the floor is underneath it. And the ultrasonic sensor tells the distance. We've also got 2 motors. And these motors, well, they allow it to drive around the map. So let's actually get our robot to do some driving. So currently our robot is there on the map. If we go into the Action tab, we can find this block called Drive Forwards. And if I click it underneath, I can say Drive Forwards. How fast do I want it to go? Let's leave it at 30. And how far do I want it to go? Let's say 50 centimeters. And when I click back on the simulator view, I can press play down here at the bottom and see that in action. So let's go. Ooh. There we are. Our robot is driving forwards. That's it. So what can we do with this? Well, we can get it to move around. We could get it to turn, actually. We've got 2 options. We can turn, which means it turns on the spot, or we can steer, which means it slowly turns. It slowly steers left. If I get to turn around, using this turn block here, I could say 90 degrees. So it's going to turn right 90 degrees. Let's run it in the simulator. Click play. Wait for it to load. So it goes forward 50 centimeters. And it turns right. That's excellent. But what happens if we want it to be a little bit more autonomous? What do I mean by that? Well, it's all very good telling the robot the exact directions it needs to get somewhere. What happens if we change it up a little bit? How happens if we got it to, let's say, follow this black line? Yeah, I want it to follow this black line and move its way around the map. So I'm going to delete the code I've got. And we're going to write the code to do that. This is one of the most useful things that you can do with a robot that's got a color sensor attached. So how's this going to work? Well, what we want it to do is we want it to hover over the black line. And if it's seeing white, it should turn towards the black line. And if it's on the black line, it should carry along it. So let's do the first part of that. Let's do, if I see white, I should turn in a direction. So it's going to need to constantly check. So we're going to need a loop. So in control, we can find this repeat indefinitely block. This means you'll do it forever. And that's exactly what we want. So I'm going to click that in place. Repeat indefinitely. I can't zoom in anymore. There you go. And what am I going to do indefinitely? What am I going to do forever? Well, what I'm going to do is I'm going to check to see what the colour underneath my robot is. And we can do that by asking if. So in control, we get an if block. If something, do something. What can we ask? Well, we can say if in sensors, we can actually get a colour. So if colour under sensor port 3, I'm going to drag that block, and we'll see that we can't actually plug it into the if. It refuses to let me. It says, no, you can't do this. This is because we need to compare this value with something. And for that, we're going to go into logic. And logic has this comparing block for us. And this comparing block, well, allows us to compare things. So I'm going to drag that in and click it into my if. And now I can get my color sensing block, and it fits right in. So what am I asking? Well, I'm going to forever check that if the color underneath my robot is equal to something, then I do whatever I want to do. How do I check what it's equal to? Well, under colors, we've got a list of all the colors we can use. So we've got if the color is white, if the color is black, if the color is blue, green, yellow, and so on. Let's start with white. So what are we doing? If the color underneath the robot is white, we want to steer towards the line. So let's pick a direction. Let's go right. Let's steer right if the color is white. So to steer right, if we go into action, and we've got the option to steer forwards, left some, right some. So the steer block here. Notice I'm not going for the one with distance. I'm going for the one without distance attached. Now the numbers here tell me how much it's going to steer. So if it's steering left 10% and steering right 30%, that means that the right motor is going faster than the left motor, which means the whole robot will turn left. Let's change those numbers around. We want it to go right, so we need it to, let's say, go left 30 and let's go right 10. So just swap those numbers around, that's all I've done. Let's test it out. Let's see what's going on with our robot. So I'm going to click the simulator, open up larger. When I move my robot around myself, we can see that this dot on the robot changes color. That dot is what the color sensor is seeing. In fact, we can get a better view of what the color sensor is seeing if we use, down in this bottom row, this sort of icon down here which says open, close the sensor's data view. And this gives us all we need to know about our robot. So currently, the robot is seeing white, and as soon as I move it over this blue block, it says it's seeing blue, seeing yellow, seeing green, seeing red, and seeing black over the line. Let's test what our robot does so far. Remember that we told our robot, if it sees white, turn right. Let's click play, wait for it to load, and there we are, it's turning right. It's not very useful, is it? I mean, when I stick it on the line, well, it just carries on. We've just created a robot that does donuts, nothing else. Let's fix that. Let's press stop. So we're saying if it's on the white, it goes right. Well, if it sees black, then maybe it should go left. It should switch the direction of travel. So we're going to do that exactly the same as before. We're going to need an if block, which we find in control. And I'm going to stick it on underneath. Notice it's still inside the repeat. I'm also going to need a comparator, and I can get the comparator from the logic. Something equals something, that's a comparison. And plug it into my if. Now we need to get sensor data. So sensors, get color sensor. And now we need to compare it with a color. And we can find the colors in the colors tab. So if the color of the color sensor is white, go right. If the color of the color sensor is black, we need to steer left. So if we go into action, we can find the steer block. Steer forwards, left 10%, right 30%. I'm going to grab that one, stick it in. And that is, well, we're pretty much good to go. Let's click the simulator. If it wants to open, there we are. Thank you very much. And I'm going to drag my robot and I'm going to stick it just on the line. Let's click play now. So it's seeing black, so it turns left, seeing white, so it turns right. And when you combine those together, you've got a robot that will follow this line all the way around, albeit quite slowly. Let's speed this up a little. I'm going to click stop, close the simulator, and let's change the turning speed. Let's change that to 60, and that one to 20. Let's change that one to 20, and that one to 60. Let's see if that goes any faster. Nope, I should probably put it on a black line. Doesn't quite work. And the reason for that is because it's going too fast. What happens is sometimes it works, but most of the time it's moving over the black line so fast that it can't actually tell what's there. Oh, and of course, it's demonstrated my next point quite nicely. It's managed to get stuck on this block. This block you can move around and is all like an obstacle. It's as if someone had dropped a concrete block on the map. Now, before I go on to the next section, do you see that red flashing bar on the robot? That's the touch sensor. That's how the robot knows when it's touched something. So perhaps we can use that to our own advantage. Perhaps we should have it so that if it hits the block, it could, I don't know, reverse away or just hide or whatever. Let's click stop. So how do I get it to reverse if it senses it's touched something? Let's go, well, we're going to need an if statement, of course. That's how we test what happens. And I'm going to stick this underneath our other two ifs, but making sure everything's still inside this repeat block. We're going to need another comparator from logic. And rather than getting the color from the color sensor, I'm going to get the touch from the touch sensor. So sensors. And we're going to use this block here, touch sensor port 1 pressed, question mark. So if the touch sensor in port 1 is pressed equals what? What does the touch sensor output? Well, it only outputs two things. It outputs whether it has touched an obstacle or it has not touched an obstacle. So it's going to be true or false. And we can find true or false if we go into logic. And there's this little block here labeled true. So if the touch sensor is pressed, if that is true, we should reverse a little bit. And we can reverse by going to actions. We can say drive however much. This one says drive forwards at the moment, but we're going to use that and we're going to change it. So the first item in the actions menu, I'm not going to drive forwards, we're going to drive backwards. And let's say drive backwards, yeah, let's say 20 centimeters, that's plenty. We don't need to go any further or any less. Let's see if that works. We should have it so that our robot will follow the line. Oh, let's change these back to something a bit more sensible, because it was going too fast earlier. So I'm going to stick my robot on the line, and if it touches an obstacle, it should reverse and then carry on looking for the line. Let's click go. So the robot's following the line, doing it all autonomously. It hits an obstacle, says, oh no, I've hit an obstacle, let's reverse. Trouble is, our robot's going to be doing that forever. It's gone stuck in a loop. But that's part of the complex, problem solving required in making robotics. How do you get a robot to fix itself when it goes wrong? Well, that's a little bit advanced for what we're trying to do with this website and today. But that's a nice little brief introduction to just working with the robot and what the color sensor does. And using that knowledge, I'm going to move us on to the nice true project of today. And we're going to design a game of Robot Twister. So let me explain Robot Twister to you. I'm sure everyone knows what Twister is. You've got the large plastic map, and on it you've got circles of different colours, and you play it as a game, and someone spins a spinner, and it tells you which colour to put a certain body part on, and you all get twisted up, and it's a good fun game. We're going to make our own variation on that. We're going to make our own sort of map and a robot on it, and the robot is going to tell us what limb should go on what colour or what square. So you can either delete your code here, or you can click this little menu button and click New. I'm going to do that, and I'm going to click OK. And we are good to go. So, what do we want our robot to do? Well, in our game of Twister, we're going to have our robot pretending to be the spinner. So we're going to get the robot to spin around in a circle, but we're not going to tell it how much it's going to spin. We're going to get it to spin a random number. And once it's spun a random number, it's going to drive off to some corner of the map, and we don't know where. So that's going to have to be random as well. So let's do those two things first, and then we can look about programming the rest. So, to move our robot, to get our robot to spin, we're going to need a turn block. And you can find the turn block in Action. We want action, turn right, however much speed, and however many degrees. So We don't want it to turn 20 degrees because it'll just turn 20 degrees every single time. We want that to be random. So I'm going to grab this 20 out of the degree slot and plonk it in the bin, because we don't need that. We're going to make this a random number. Now, to grab random numbers, we're going to have to go into advanced mode. And that's very simple. You need to click this little star up here. In the top left-hand corner, you should see a tab which says star 2 on it. When you click on it, suddenly it gives you a lot extra menu options. So we've just gone from simple mode to advanced mode. Now we can find our random number chooser over in math. When I click math, it gives me lots of maths operations. And if we scroll down to the bottom, we can get random integer from 1 to 100. And that's exactly the one we need. We need a random integer, a random whole number. I'm going to grab that and I'm going to plug it into the degree. Let's say we don't want it to go from 1 to 100 because 100 degrees, it's not even a half turn. It's about a third of a turn. So let's change that to a higher number. Let's change that to 1000. And while we're at it, let's also change the speed of the robot. Because if you're trying to play a game of Twister, you don't want the spinner being agonizingly slow. So let's change this number to 100. Let's change the speed percentage. Let's see where we've got so far. So when I click play, the robot should spin around in a circle, but I won't know how far it will spin. Let's click play. There we are, it did about 3 complete turns and a little bit extra. And play again, and we'll notice that it does a different amount of turn. Oh, that was a very small turn there. Excellent. Now we can do the part where it drives off a random distance. So, of course, this is an action. And notice how the action menu has changed. Now we've gone into advanced mode. You can find this in Drive, in the Drive submenu. And we're going to drive forwards a certain speed and a certain distance, like the turn. But I'm not going to go 20 centimeters. That needs to go in the bin. I need to go, again, a random integer. So, into math. Scroll to the bottom, random integer. And we want, let's leave it at 100 centimeters. We don't want to go too far, otherwise the robot will drive off the edge of the map. And that would be a disaster. We don't want that. Random integer for 1 to 100. Let's see what our robot does. So, spins around in a circle, then drives forward a random distance. Perfect, we've got the first 2 parts down. Let's just speed up that second part though. Let's speed up how fast it drives forward, otherwise we'll be here all night. And I just don't have the time for that. So, what do we want to do next? Well, our robot needs to decide what it's going to make the players do. What limb does the player have to move to what location? Well, we're going to need another random number for that. We're just going to have to randomly choose some value and then say, depending on that value, choose which limb. Now, I've mentioned the keyword here. I've mentioned values. We're going to have to use values, and whenever we use values, we store them in a variable. So, this is slightly different to how we've done variables in the past. When it comes to using robots like this, they like their variables to be declared before the start of the program. So if you click the plus on start, it allows you to declare a variable. So the first part of this block is where we put the variable name. Now this is where I'm going to store a number that tells us what the body part is. So what am I going to call this variable? Let's call it something like, I don't know, body number. Now the next part here is where we tell it what type of variable this is. And if we click this drop down arrow, we can say, is it a number variable, a Boolean variable, a string variable, color, connection, so on, so on, so on, so on, so on. We just want number for this. This is just storing a number. And what number is it storing? Well, it's storing 0. We're good to go. Let's set this variable to a random number. If we go to variables, we can find this block called set body number to something. And I'm going to grab this block and I'm just going to stick it underneath. We want to set this to a random number, so we're going to need the random integer again. So math, random integer for a 1 to 100. I'm going to grab that. And, well, I don't know about you, but not everyone has 100 arms. Let's change that to 4, because we're going to choose between 4 limbs. Right leg, right arm, left arm. So you want to choose a random integer from 1 to 4. So what's going to happen? Well, our robot spins around, moves forward, and then it chooses a random number from 1 to 4 and sticks it in a variable. It saves it to a variable called a body number. And what we're going to have to do now is we're going to have to say, if the body number is equal to 1, then we're going to use right leg. If it's equal to 2, we're going to use left leg, and so on and so on and so on and so on. So we're going to need a large multi-part if statement. And if we go to control and into decisions, we can use this if here. At the moment it's a simple if. Let's leave it as a simple if for now. We're going to work with the first part of this puzzle. We're going to say if the body number is, let's say, 1, we can say we're going to use the right leg. So we're going to need to use a comparator, which we can find in logic. If that should have body number in it, so if body number equals 2, and we need to stick a number in. How can we grab a number? Well, if we go to math, it has a number pre-made for us. If body number is equal to 1, do something. Now, how do we store the decision? We're going to need to store something. So, another variable, perhaps. Let's click the plus at the top of start. And I'm going to call this, let's say, the body part variable, because it's going to store which body part we're talking about. And I don't know about you, but I don't call my limbs number 1, number 2, number 3, number 4. I give them names, right leg, right arm, left arm. So this isn't going to be a number variable. This is going to be a string variable, and that's very important to get right. String is any bit of text, and, well, this is text, it's not a number. So body part string. We can see that it's changed the blue number block to a green string block. And that's all we need for now. Now we've seen whether and what value body number is, we can start assigning the body part a value. So if you go into variables, we can say set body part to. Now, what do we do with this? Well, we need to set it to a string that correlates to the name of one of your limbs. So I'm going to go into text, and I'm going to grab this top string empty block. This represents an empty string that I'm going to put some text in. And as it says there, a letter, word, or line of text. And I'm just going to plonk it in. So set body part 2, and this is where I put down the name of the limb. Let's go right leg. And that's the first part done. What happens here is if the robot decides on a random number, and that random number turns out to be 1, then it's going to start talking about the right leg. It's going to do some more with that information afterwards, but we're not gotten to that yet. We're just going to work on filling out the rest of these. We've got right leg, we need left leg, right arm, left arm. So we need to add more to this if. Now, I could do it by sticking more if blocks in, but that's not very elegant. It's not very computer programming. It's not the best way of doing it. It's much better to do this with an else if. And I get those by pressing plus here in the if block. So I've already got if body number equals 1. Well, if that's not the case, then I need to say if body number equals 2. So let's start filling these out. So it's an if, I'm going to need a comparator. I'm going to get the variable name. And then I'm going to get a number from math. And then I'm going to change that to 2. And if the body number is equal to 2, then I'm going to set body part to something else. I'm going to go set body part to, grab that from text. Let's have this as left leg. Now, I could be very mean here, and I could have you filling out the rest, which will take ages. Or I could show you how to copy and paste. Yeah, I'm going to do that. So let's add the next else if in. Let's click plus. Now we know that we're going to need a comparator block with the variable name and the number. So why don't I just copy and paste it? So I'm going to right click on this blue block that I've already filled in, and I'm going to click duplicate. And I've got instant second copy. Now, as always with code, when you're copying and pasting, always remember to change the values. You'll be surprised about how many errors there are out there in the world that only happen because someone's copied and pasted and forgotten to change a number. So I've changed the 2 to a 3. Let's also duplicate this block here. Set body part to left leg. Well, let's duplicate that. Stick it underneath. And this is going to be right arm. Last bit, let's add another else if. And of course, I'm going to have to duplicate this again, making sure I don't forget to change the values. Nope, don't want a 43, I want a 4. And then we can duplicate the body part assignment. And let's change that one to left arm. Right. I think we're ready to move on. We've got it so it's telling us, we've got it so it's thinking of a limb for us to move, but how do we communicate that to the user? How do we get the user to know what the robot is doing? Well, interesting thing about these robots is, well, they've got a screen, so we could display it on the screen. But thinking about that, the robot's going to be driving all over the floor. You're not going to always be able to see the screen, especially not if you're playing Twister at the same time. So why not have this as an audio cue? Let's have it actually say things out loud. If I go to Action and the Sounds submenu, I can have it play a note, I can have it play a file, or I can have it say something. I'm going to use this bottom say block, and I'll show you why in a bit. But say, I'm going to stick it underneath all that. What do I want to say? Well, I don't want to say hello, so I'm going to delete that. I want it to say whatever the body part is. So let's go variables. Let's grab body part. Notice I just stick the body part straight into the say block. I think we're ready to test. We're ready to see what our robot does. Let's just quickly do a dry run. A manual run through of our code. The robot turns around in a circle a random amount. It drives forward a random amount. It chooses a random number. Then in this if block, it says, depending on what that random number is, assign that random number to a different limb each time. So if it's 1, assign it to the right leg. If it's 2, left leg. If it's 3, right arm. If it's 4, left arm. And then say whatever one we chose. Let's click that simulator button. Let's see it in all its glory. Let's click play. Wait for it to load.
Right leg.
I don't know whether you heard that, but it said right leg. Now, that's the first part of Twister, but if you've ever played the game, it's a little bit more involved than that. You say right leg to green, or right leg to red, or right leg to whatever colour dot there is available on the Twister mat. So you want it to say more. We want to have it give us more information, more detail. So where I've got this say block and it's saying body part, I'm going to drag that out for a moment and I'm just going to leave it sort of hanging off there. And the reason I'm doing this is I wanted to say multiple things at once. But the problem is I don't want to use multiple say blocks. I don't want it to go like this. I don't want it to go say, and each time, because if I do that, there's going to be a very long gap in between each thing the robot says. What I really want to do is I want to add all the things it wants to say together in one sort of mini block. And because that's all going to be text, I can use this with something quite advanced that we call text concatenation. And you can find that in the text block here. And it's this one here, create text with. And what this does is it adds two strings together. It joins any two bits of text together and forces them to be one. So let's grab that and let's stick it in the say block. And now we can attach our body part that we left hanging off to the edge. So what am I going to add to this? Well, I want my robot to say out loud, right leg goes to, and then whatever colour the robot senses. So let's add in the goes to part of that sentence. That's a string. I need to add in a string, so I'm going to go to text, and I'm going to grab this green text block. And what am I going to have to put in here? Well, I'm going to have to put in goes to. So right leg goes to something or other. What does it go to? Well, let's say we have something underneath our robot. Let's say it picks the colour that it's on and it tells you what that colour is. And I can do that by getting the colour sensor. So in sensors, we can find this get colour sensor block that we used before. And I'm just going to put it there for now because we've got nowhere to put it. How can we add more into this? Well, luckily, this little plus button in the create text with block adds more, lots more. I could keep adding text and text and text and text until I've written a whole book. But I'm just going to use 3 for now. I'm going to add body part plus goes to plus whatever the colour sensor is. Let's give it a go. We need to do a little bit more tweaking to this, but it's pretty much almost finished. Let's click sim. And let's click play. So just to remind you what happens, the robot turns around in a circle, goes forward.
Left arm goes to WHITE.
And it's, hang on, why is it spelled out the colour for me? That's very odd. It's meant to say robot goes to white. And the reason for that is that we're adding bits of text together. And we're creating a sentence, basically. And one thing we've forgotten to put in our sentence is spaces. So if we look at body part, we can see that it's made out of right leg, right arm, or left arm, depending on whatever those are. None of these bits of text have a space after them. So what that means is there's no space between body parts and goes to. And then if we look at goes to, there's no space after the to, so there's no space between to and whatever the colour is. I need to add these spaces back in. And I can do that very simply just by going to the goes to part, and I bring my cursor to the front of it with the arrow keys, and I put a space in there at the start. So now there is one space, and I put a space in afterwards. So there is now a space before and a space afterwards. And that's the tricky thing you've got to remember when adding strings together, is it doesn't automatically put a space between everything you add together. You have to do that yourself. Let's see if it works better now.
Left leg goes to white.
And that's perfect. Let's play again.
Left arm goes to white.
Brilliant.
Right leg goes to white.
Okay, so it's saying white a lot. And that's because this isn't a good map for us. Let's try a different map. Now, luckily, OpenRoberta has several maps loaded for us, and we can change map by clicking this little picture icon down in the bottom of the simulator. So I've got this one, which is a completely white map. I've got this one, which is kind of like a countryside road thing. This one, which is a challenge where you've got to follow the line. Remember, we did follow the line at the start of the stream. This one's all on green, and we're back to the start. Now, I don't think any of these are great. Luckily, I've produced one for you. Let me just get the link up. Bear with. There we are, that looks fine. Now, if you go to a new tab and you type in bit.ly/Technocamps-Code Club. Let me stick that in chat whilst that loads. You get to the page that's all about the Technoclub and all the resources that we have on that. And on this little menu on the right, it covers all the previous code clubs that we've done. And if you go to the last part of this by clicking this dot here, this is today's. You can always come back here to rewatch a stream if you missed it. Now, this is Robot Twister. We're going to be using this image here. We're going to load this image straight into our scene. So if you right-click on that, we can save image as. Let's save it. I'm going to stick it on my desktop. It's called Color Grid. If we go back into Roberta Lab, we can upload your own simulation background image. And that's this button over here in the bottom of the simulator on the right. Let's open the color grid. This is just a warning about cookies, basically saying, do you want us to remember this image? Okay. And you should have something a bit like this. Do you know what it reminds me of when I was making this? It reminds me of that, what's the name of that book about the colourful elephant? Elmo the elephant? Something like that. I can't remember, it's been years. Before we start, I'm going to move this little block. Remember, this is the obstacle block. I'm going to move this block out of the way because we don't want our robot colliding into anything. Let's see if our code works. Let's click play. Robot
Right leg goes to yellow.
There you are. Robot spins around, goes a random distance, and tells us what square it's landed on. You can click play again.
Right arm goes to yellow. Left arm goes to yellow.
For goodness sake, 3 yellows in a row. Come on, let's go for a better colour.
Right leg goes to red.
There we are. Perfect. Yeah, that's pretty much it. Let's just tidy up our code a bit. Let's add a little bit more flavour to it. It's a bit of a... it's not such a great game if every time you have the robot choose its location, you have to get up and you have to go again. So let's get this to repeat. I want this to repeat indefinitely, so I'm going to go into Control, and we can find this Loops button here, and we've got the option to repeat indefinitely. And I want it to cover all of our code from start downwards. So I put it in after start, and then I take the rest of my code and I stick it in the repeat indefinitely. Now, yeah, let's give that a go. Let's see what we get out of that. Let's click play.
Left leg goes to white.
Spins around.
Right arm goes to white.
Didn't go far enough then.
Right arm goes to red. Right leg goes to red.
Bit stuck at the bottom. I'll help him out.
Left arm goes to yellow.
And so on and so on and so on. We've basically essentially made our own spinner for a game of Twister. I can make the voice a bit better. Now, your voice will depend on what computer you're using. When I use a Windows computer, it uses a female voice, but when I use a Mac, it uses a male voice. But depending on which voice it uses, I can change the pitch. I can change it to be a very low voice by making this a low number. Click play again.
Left arm goes to white.
That was very low. Let's make it huge. Oh yeah, 1900, that'll do.
Right leg goes to white.
Quite high pitch, and we can change the speed. So let's make that really slow.
Left arm goes to white.
And so on. And there we are. We have a complete program. If you wanted to expand on this, there's a nice little thing we can do. If you made two new variables, let me start by making one. Let's call this, I don't know, distance traveled. If instead of choosing the random distance that I travel here, I instead put that inside the variable, and then I get it to move the random distance. What I've basically done is I've kept a record of how far it has travelled. So what I can do then is, rather than starting again, I could get my robot to move back to the beginning. And I can do that by, if I go into action and drive, I can have it drive backwards, and all I need to do is just reuse that variable. If I go into variables, distance travelled. So fingers crossed, if it doesn't hit a wall, it should spin around.
Right arm goes to blue.
Oh, I forgot it was on slow. And then it travels back to the
Right
centre.
leg goes to black.
Back to the centre. Let's hope it goes a long distance now. There you are.
Right arm goes to red.
And it'll go back to the centre. Maybe I should speed that up a little. It's a bit slow.
Left leg goes to green.
And so on. So you can get it to return to the centre every time. And I'm going to leave you with that. If you want a challenge, try and get it so that if it does hit the edge, it reverses a little and decides where else to go. But other than that, I hope that's been an interesting stream and you've enjoyed having a look at this website. If you have an account, you can actually save the program, but you need to be logged in to do that. In any case, I hope you enjoy, and remember that I'll be sticking around both on stream and also on the Technoclub's website and Discord if you need any help. And yeah, good night.